In physics, it is the condition of a system when neither its state of motion nor its internal energy state tends to change with time. A simple mechanical body is said to be in equilibrium if it experiences neither linear acceleration nor angular acceleration. Unless it is disturbed by an outside force, it will continue in that condition indefinitely. A rigid body is considered to be in equilibrium if the vector sum of all torques acting on the body is equals to zero, so that its state of rotational motion remains constant. There are three conditions for equilibrium: the first condition, the second condition, and the two component forces. For an object to be in equilibrium, it must be experiencing no acceleration. This means that both the net force and the net torque on the object must be zero. In the form of an equation, this first condition is F net equals to zero. In order to achieve this condition, the forces acting along each axis of motion must sum to zero. For example, the net external forces along the typical x and y axis are zero. This is written as net Fx equals to 0 and net Fy equals to 0. The condition F net equal to 0 must be true for both static equilibrium, where the object's velocity is 0. The motionless person is in static equilibrium. The forces acting on him add up to 0. Both forces are vertical in this case. The second condition is necessary to achieve equilibrium. It involves avoiding accelerated rotation. While there is only one way to write the conditions for the forces on a rigid object summing to zero, we have a choice in the way we write the equation for the total. A rotating body or system can be in equilibrium if its rate of rotation is constant and remains unchanged by the forces acting on it. The magnitude of torque about the axis of rotation is defined to be torque equal to Rf sine theta. A trial seesaw shown in is an example of static equilibrium. An object in static equilibrium is one that has no acceleration in any direction, while there might be motion such that motion is constant. In two component forces, an object with constant velocity has zero acceleration. In Newton's second law states that summation F equals to ma. So objects with constant velocity has zero net external force. This means that all forces acting on the object are balanced. That is to say, they are in equilibrium. In each direction, the net torque take the form the summation T equals to I alpha equals to 0, where the sum represents the vector sum of all forces and torques acting. This rule also applies to motion in a specific direction. Consider an object moving along the x-axis. If no net force is applied to the object along the x-axis, it will continue to move along the x-axis at a constant velocity with no acceleration. We can easily extend this rule to the y-axis in any system unless the applied forces cancel each other out. There will be acceleration in the direction of the resultant force. Static systems in which motion does not occur, the sum of the forces in all directions always equals to 0. This concept can be represented mathematically with the following equations. If the resultant moment about a particular axis is 0, the object will have no rotational acceleration about the x-axis. If the object is not spinning, it will not start to spin. If the object is spinning, it will continue to spin at the same constant angular velocity. Again, we can extend these moments about the y-axis as well. We can represent this rule mathematically with the following.
Created using PART1.